So to start, we're going to change the whole title to section 7.1, which starts on 572. We're going to change the title, stroke out the word graphically, to Solving Trig Equations, the General Solution. And then we're going to skip the getting started and skip the construct the understanding, and you have space. Well, you can already start on page 572 if you like on the left-hand side, and then you can continue with the space on page 573. This is our warm-up. And this is the reason that we're doing chapter 7 before we have our chapter 6 test, because it's the same thing we've been doing already. We're going to add a little bit new that's not going to be on your test, but the rest of the stuff is all review. So here, you have solve for theta between 0 and 2 pi, including 0 and including 2 pi, if you had 3 sine theta equals -2. So you can solve that one. I'll give you a little bit of time. If you get ahead of schedule, you can start the next one as well. This is not in your textbook, but you can write it in the space on the side of 572, and then you can also write at the top of 573. So I've got 4 different ones that we're going to be looking at. Check how you did on the first one. Did you get a reference angle of 0.730? So if it doesn't say in a question, they want you to round to 3 decimal places. And then, well, I didn't round to 3 decimal places here, oops, but those would be your 2 answers. Next year in grade 12, you always have 3 significant figures. This year it's 3 decimal places. So it changes a little bit from grade 11 to grade 12. So we find our reference angle, and since sine is negative, quadrant 3 and quadrant 4. For the second one, get tan by itself. Find your reference angle. Tan is negative, so quadrants 2 and quadrants 4. Okay, without a calculator, how'd you do on the first one? It's not possible, because you get an answer that's bigger than 1. You could change that to a fraction, right? 4 over 1, meaning the adjacent side's 4, your hypotenuse is 1. That's never possible. So at first you get the answer and you're like, that's not on my pie plate. And you're a little bit like, what do I do? But if you do try it on your calculator, it says error domain. This is where I want to invent a calculator that actually gives you a little electrical shock when that happens. But I guess that's not good. That's why our bells are all bad. Because one of the secretaries went to call to somebody's room and got not just a little electrical shock, quite a big electrical shock. And so they have to order a whole new system. So if I call right now, they like just look at it and don't answer because they're afraid they'll get shocked. Yeah, a couple days ago there was a big shock. So they have to get a new system. And then the bells haven't been working. Now here is what's going to be new for us. Instead of solving between 0 and 2 pi, once around the circle, we now add, the general solution means you just find every answer that works. Not just once around the circle, not just twice around the circle, like 15 times around the circle, 85 times around the circle, 348 times around, anywhere. So how do we do that? Well, we start solving like we normally would. Get tan by itself. Do you recognize that value? Do you recognize the 1 over root 3 is the same as root 3 over 3? Because it could happen in an equation that it comes like that and you'll need to be like, change it. But if it's on a non-calculator part, you might get a hint that way. This should be something on my pie plate. Then we solve it like normal. right? Where's tan negative? Quadrant 2, quadrant 4, we solve it like normal. But then to solve for all the solutions, it also connects to something we already learned in chapter 6. We need, if I take out a pi plate here, and I think about 5 pi over 6, that means on the second time around, something that ends there. Third time, everything that is, what did we call this when they end in the same place? Everything that's coterminal with 5 pi over 6. How did we write coterminal? We just had it on our quiz. We have to add 2 pi times k, and so the proper way of writing this is take each of your answers, 5 pi over 6 and 11 pi over 6, and add 2k pi to each of them. And then you have all the solutions. So I have a little diagram off to the side there showing 5 pi over k and 11 pi over k. And then circles saying you could jump all the way around to get to the other one. So there's two ways of looking at this. Okay, this is the correct answer, and this is how most of you will do every single one. You're going to solve between 0 and 2 pi, and then you're going to add 2k pi to your answers to show the general solution. But with tangent, can you see that you can get from 5 pi over 6 to 11 pi over 6 by just jumping halfway around? And then jumping halfway around again? So another way of writing this answer would be just 5 pi over k, but only halfway around. And this is more elegant because it's shorter, but most of you will write it like this, the first way, and it's perfectly fine.
You could also write it was 11 pi over 6 plus k.
That's right. Or you could pick something way down, 23 pi over 6 plus k pi, if you wanted to. So that was our warm-up activity.